Through his firm Edify, John Stephen advises innovative security product firms, as well as maturing security initiatives. John leads one such firm, Zero North, as CTO. For 2 decades, John led technical direction at Cigital, where he rose to the position of co-CTO. He then founded and was CTO of Codiscope, a Cigital spinoff. After Cigital and Codiscope's acquisition by Synopsys, John was the Senior Director of Security Technology and Applied Research. He co-authors the BSIM study and serves as co-editor of the Building Security in the Department of IEEE Security and Privacy magazine. John is keenly interested in software-defined security governance at the cadence of modern development. Please welcome John Stephen to the virtual podium.
Hello everybody, I'm John Stephen, founding principal of Edify Security as well as CTO at Zero North. Welcome to AppSec Global and this keynote, as well as my home office and my son's first grade classroom. Hopefully each and every one of you is safe, sane, and healthy, and finding some unexpected joy amongst the challenges we're all struggling through right now. I'm here today to talk to you about software-defined security governance, and more generally, what's happening in application security and how what we've taken for granted and what we've matured and optimized over the last 2 decades is really fundamentally changing underneath our feet, and what we need to do about it to maintain at the fore and be effective in securing our organization's software. For years I've been talking with organizations at conferences about how the trends in development have changed the way we need to address security. Talking about how these words get jumbled up by security professionals. Sometimes security professionals struggle to figure out how to address when their developers are engaged and deeply passionate about something like agility or DevOps. And so looking at the roots of these trends, a focus on change and accelerating delivery, a focus on tools and emphasizing automation, as well as a focus on breaking down those stovepipes that we in security have sometimes built up, is one of the things that I've spoken about extensively in the past. Last year at the BSIM, the Building Security and Maturity Model, we found that firms were responding to a variety of different organizational motivations that they all wrapped up into the term of digital transformation. Digital transformation is probably the hypiest term out there, but there's real meat underneath it. And looking at where that real meat has taken things like agility and things like DevOps and either amplified it or symbiotically created more change is really important. The first pillar is this notion that developers and organizations are outsourcing much more of development than they have historically. They're outsourcing more of coding in terms of open source software. They're outsourcing IT itself to the cloud service providers. And while they're doing this outsourcing, what that's highlighting is a developer's ability to self-service more and more aspects that the organization used to provide in stovepipes. Now that self-service, when developers can go out and grab instances of EC2, or they can go out and grab whole web development or mobile development frameworks, whole MFA or authentication authorization frameworks, what that creates is a situation where, because they were able to go get it and implement it themselves, there's less opportunity, there's less of a hook for security to be involved. And that's sometimes made governance much harder for application security initiatives. Taking the outsourcing pillar and adding on to that the cultural imperative of DevOps, the breaking down of the difference between the roles of operator and developer, which you can see being symbiotic with moving to things like open source containers and cloud service provision, means that there's an increasing responsiveness to delivery that developers can provide themselves and that the engineers can avail themselves of with code that is self-delivering in some sense. But that's created a massive stress for security in terms of the cadence necessary to produce vulnerability discovery data and telemetry and provide that back to those engineers prior to release so that we can build security in. That cadence stress, in turn, has doubly amplified the importance of automation within the process of the software lifecycle, within the process of the software delivery lifecycle. And so if we're focused on that increased responsiveness, and we know that humans are the slowest thing in the loop, we're going to remove as many of the humans as possible and highlight automation. And we've seen that for years in CI/CD and in the challenge to security tools, in participating in those automation pipelines and at the cadence that people need in order to do what they want to do, which is continuous or extremely low latency delivery. And that has, in fact, created sort of an unwinnable war for a lot of security initiatives that are reliant on legacy, maybe big box tools. Now, there are tools out there that will tell you that they've got the solution to this problem, that they fit within the DevOps cadence, that they support DevOps culture natively. And there are tools that do a better job than others. But I'm here to tell you that studying security initiatives and looking at these tools in great depth myself, there simply is no silver bullet DevOps security tool. There is no one tool that puts the sec in DevOps. And in fact, all of these tools fall prey to something I've been speaking about in keynotes here at OWASP for years, which is that they can find a percentage of the vulnerabilities. And no tool finds a majority of the vulnerabilities, let alone all of them. So even if there was a tool that was perfectly aligned with these two pillars in the middle, I'm here to tell you that your initiative, if it's strong, and if it desires maturity, is going to need to combine the telemetry from multiple tools, not a single silver bullet tool, in order to be effective. There are vendors out there that tell you that they can sell you all the tools necessary. That's a bit far-fetched as well. I don't see any portfolio of tools that one can buy from a single source that covers all the bases for security vulnerabilities, for tech stacks, and for organizations. And finally, other imperatives are affecting the speed at which we can do security and our accuracy and the way we mature our security programs. More and more, we are going to a microservice orientation. In concert with the desire to deliver continuously, we're delivering smaller chunks of thing. In concert with our desire to be agile and recognize we don't know necessarily what the customer wants day one, we are building smaller and smaller parts, combining open source and other cloud service provider marketplace items into microservices, and delivering fabric or meshes of those things rather than monoliths. And because of the microservice orientation, because of our ability to self-service packaging and delivery, we're able to reach for the brass ring of leverage and say, not only can I incorporate open source into my build, not only can I containerize elements of my software, not only can I provide microservice architectures, but in fact, what I can do is I can provide software-defined applications through things like infrastructure as code, through things like orchestration, and I can create leverage out of those Lego pieces that I've created architecturally, code component-wise, container-wise, network infrastructure-wise. And so these last two pieces really challenge the technologies that we've used historically, as well as the governance techniques we've used historically to drive security. Now, digital transformation, though hypey, is an interesting thing to pay attention to from a security perspective, because this notion of self-service and outsourcing, the notion of culture change, the notion of automation, the notion of an architectural paradigm shift, as well as a desire to leverage and provide infrastructure as code and orchestration. Those 5 waves, when taken together, create a sea change, just like the web did when we were all programming C and C++. And so paying attention to each of these 5 trends, we may be able to ignore them for a period of time. Looking at all 5 in concert and how they combine in a firm's digital transformation means that we can no longer ignore these imperatives, and that security is going to have to address these challenges with subject matter expertise in new technology stacks, cadence stresses, as well as an overwhelming need to automate to the point of developer self-service. Now, you've probably heard pieces of this puzzle over the last 2 or 3 years. What I'm here to tell you is that the digital transformation train is leaving the station for larger and more mature development organizations. We had the thought leaders in terms of Netflix and Amazon, Etsy, others who have really made developer self-service their calling. And you've seen those individuals from those organizations present at conferences like this, showing how you can automate pieces of delivery, automate pieces of security telemetry. The average firm, we are now engaging in the BSIM study, is got an aggressive digital transformation initiative. And so these 5 imperatives are going to drive the average firm. And so it's not just the pointy edge of the spear industry-wide that's handling these problems this way. It's the mass of the shaft. Continuing on this slide, instead of jumping ahead, there are some really interesting things happening in each of these categories that have added security to the behaviors of development. It truly builds security in, as opposed to waiting for them to create something and telling them the baby's ugly. When you saw the transition from Java to JavaScript, when you look at languages like Go, Rust, and others, the web development frameworks that are coming out in these more modern languages, despite some of the language theoretic challenges of things like JavaScript, the languages themselves, like Golang, are thinking about security from the ground up. And the web application development frameworks are thinking about things like contextually aware output encoding, password storage, authorization authentication in the box. And they're providing primitives that developers can use effectively to build secure systems. When you look at what's happening in SDL, GitHub and GitLab have robust and very thoughtful security frameworks and security manifestos built into the way that their pipeline products work. And so what was security champions implementing vulnerability discovery tools in Jenkins is now a very natural process with GitHub and GitLab pipelines, of either on and secure by default security tools or easily added ones. What we're seeing as we move to the newer technologies, things like containers, things like infrastructure as code, is that our security tooling isn't as robust there. And so, whereas we've got, great technologies, in web development frameworks, we've got open source tools, we've got built-in capabilities in SDL and Marketplace, we've got open source and cloud-provided tools in terms of containers and orchestration. We've got infrastructure scanning tools, both commercial, cloud-based, as well as open source. We've got this sort of miss in configuration management, which we'll look at more as we proceed. what does this mean? As we study firms and we look at the difference between central security initiatives, legacy application security, and what engineering-led firms are doing, or what just simply engineers are doing to build security in for themselves, there is a generational gap emerging. What does that mean? Well, looking at the blue line, we see that, this is a notional graph, right? There's no axes or sort of legend here, but 10 years ago we were talking about CI/CD from a security and development perspective. We started to talk about the impact of outsourcing to the cloud and the cloud service providers' security controls, well architected, building for cloud securely, cloud native security, container security. What we've heard over the last year to three is as a development organization, we want to take all of the things that we built to transfer our applications to the cloud, and we want to remove the manual effort from that delivery process. We're going to aggressively go after replacing all of our SRE's behaviors with infrastructure as code. So what they did for build and delivery with CI/CD, we're now doing for delivery to the cloud, and in fact provisioning of the cloud assets, creation of the containers, combination of the containers, and weaving the microservices into fabrics or meshes. And what we've seen in the BSIM study over the last 2 years is that development executives are saying it's not good enough to simply convert what we did in the past to infrastructure as code. We have to be able to make the developer self-service in the ability to instantiate a delivery capability. We want not only infrastructure as code, we want pipeline as a service. So if we decide that a new business line wants to stand up the capability to deliver a mobile app and a backing service, we want pipeline as a service that the development team can snap their fingers and instantaneously have the delivery capability associated with that. Now, when they do that, they're adding all kinds of non-functional requirements to those pipelines. When they're doing a good job, they're adding unit testing, they're adding integration testing, they're adding linting for their coding standards. They may add, Chaos Monkey or other things that allow them to do availability testing or other kinds of non-functional requirements testing. Of the 5 organizations with which I worked over the last 12 months intimately, all of them were working on pipeline as a service across the board, not just in the cloud teams, not just in the digital transformation teams, but across the board. And in fact, at least 3 of those 5 were at a point where a team could be brought into existence and they could snap their fingers and create a delivery pipeline associated with the tech stack they wanted, and get a lot of those capabilities that I just described for free and on by default. Now, I spoke with an executive who ran a security initiative just last week, and this individual had just joined a new organization and said, I need to be able to integrate 3 to 5 tools with the CI/CD pipeline in the next 9 months. That's what we see in this red line here. There's a big gap between what development executives are trying to do, snap your fingers and get a delivery capability with on by default assurance capabilities, and what security is still talking about. How do we integrate with CI/CD? And as we look at that driver of self-service, as we look at what a developer is able to do for themselves to generate, integrate, deliver, and then operate applications, if we're still at the point from a security group perspective where we're trying to convert manual CI/CD integrations to champion-driven security integrations, where we spin up a group inside of our development population to do that. Or we're beginning to ask the question, what would it mean for security tools to be run by default when a new CI/CD pipeline is built? We're a few generations behind, because when we haven't begun to ask the question, what are we going to do for the cloud configuration and all the instances being stood up, all the containers and marketplace items being pulled down from the cloud service provider? What are we going to do to look at all the infrastructure as code and all the automation associated with not only the infrastructure as code, but in the pipelines that is housed in and executed and that create it? Developers have gotten to the point where they can self-service IT, self-service major enterprise applications like RDS directory, authentication, MFA, Postgres. In fact, their pipelines, not just their build pipelines, but their full delivery pipelines. And in security, we're still wondering how to integrate with CI/CD. So if your organization, if you are still trying to solve that problem, the developer's ability to deliver is going to exponentially outpace your ability to govern. And so this is the gap that we have to tackle. Now, when I speak with a lot of security owners, SSG owners, they complain about the myriad of technologies that their developers are using in order to get this level of self-service. They may have a handle on Maven, they may have begun to get a handle on Kubernetes, but they may be struggling to figure out what to do about things like Terraform and some of the other technologies, Istio, Helm, Ansible, and Chef. Why do these things exist? Increasingly, if engineering is going to be self-service, building pipelines as code, building infrastructure as code, more software is more complexity. These technologies have something in common. They render the operating layer at which they function configurable by something like JSON or YAML. So, when you look at a technology like Terraform, what you're enabling engineers to do is consistently generate instances and topology to connect those instances or house it with configuration. If you think about Maven, you're rendering the dependencies in the build in your environment configuration. When you think about Kubernetes, you're taking a bazooka to the challenge of how you combine these components into an application and run them in a cluster, or on virtualized hardware, and manage the choices you have there. Istio and Helm, are they just like Kubernetes? No, they're an orchestration layer that layers on top of it, and that allows configuration to drive more complex relationships, or service level agreements between those components, whether it be encryption east to west, whether it be resource usage, whether it be the way they connect and how they discover each other. Ansible, Chef, and Puppet, many people are familiar with these things, at least notionally. These are technologies that render into configuration all of the different things you're going to forget to do to set that Postgres server up or to set that Nginx server up correctly with the application you want to run, and make sure that everything is going to function the way you expect it to. Converting all of the operator, packager, deliverer steps to not just script but config. We'll get into it. These technologies, because they're controlling the things I just described, have an outsized impact on what the security posture of the resulting service mesh or application looks like. So naturally we ask the question, what security scanners can we run on this configuration to see if we've got SSL right, to see if we've got the encryption right, to see if we've got identity right, to see if we've got trust right? The answer is unfortunately not much, with the exception of the flagship product, Dependency Tracker, that comes out of OWASP. and composition analysis for those dependencies, which ultimately end up in the containers, we don't have a lot of weapons to bring to this battle, even though these technologies are using or are gaining traction. Laurie Williams just did a study on GitHub in terms of the publicly available repos. She and her team believed that infrastructure as code and the material associated with these technologies in these slides may account for between 6 and 11% of the public code base. I think that number is probably low in your organization if your organization has committed to digital transformation based on what I've measured. It makes sense that maybe publicly available open source, technologies may not have necessarily, taken the sort of paid time to do as much conversion as maybe an organization has. The second thing that study showed was that 30%, like 29% of the churn on a monthly basis for the code bases that are checked in is this infrastructure as code. So when we think about software security and we think about looking at where the technologies have the outsized impact on a security posture, we have to think about these technologies. And yet when we go out to buy our vulnerability discovery tools, these things are not supported. We see Go, we see Swift support, we see all kinds of different things. We don't see Ansible, we don't see Terraform. What can be done today? Well, software-defined everything means more software. And from an engineering perspective, engineers are picking, again, languages and frameworks to do a better job bringing some of those security features we've asked for in threat models, and we've found vulnerabilities with our scanners in for years. Looking at a modern recent version of Django or even Flask, looking at Golang web development, looking at what the JavaScript ecosystem provides you, again, you're going to get contextually aware output code encoding for free. Almost all of those frameworks that I mentioned store passwords with a adaptive one-way cryptographic function as opposed to with just a hash. Many of those technologies, Flask accepted, provide an authentication framework. Flask, you can download one. Many of them provide an authorization framework behind their authentication framework, encryption libraries, and so on and so on. So the dream of a SAPI is kind of dead, but the dream of the concept of having security primitives baked into a framework which developers can then leverage is very much alive. And these framework maintainers have done a frankly great job of making sure that these technologies exist and they're on by default where it's not too painful. So upgrading to languages and to web or mobile development frameworks that are modern gives you a huge leg up on the OWASP top 3 class of vulnerabilities: the SQL injections, the cross-site scriptings, the cross-site request forgeries, and what I've found historically in my career have been a key class of top 3 vulnerabilities: failure to demand authentication or authenticating but not authorizing correct use before dispatching a privileged action or entity. Moving to these technologies is going to help us. We need to do the same thing when we think about the recipes, the code snippets, the config snippets, the templates of configuration that define our infrastructure and that define the manipulation or the orchestration of our infrastructure as well. Right now, there are, what developers are doing is they're cut and pasting either Terraform scripts or CloudFormation templates or whatever they're using, and that reuse is exceptional. However, that reuse is a double-edged sword. To the extent that the snippet of configuration that they've built is secure, then we're getting leverage out of it. To the extent that it's insecure, what we have is a scenario where the leverage they're able to get out of this infrastructure as code and configuration means that they're going to replicate the vulnerability throughout their organization much more extensively. The first thing we can do beyond moving to these modern frameworks is to leverage the open source scanning software that's out there to make sure that when developers use these more effective, more secure frameworks, that they're using the security controls everywhere they need to, that they're not turning off the secure defaults, that where there aren't default behaviors like session management is one where you really have to tweak and twiddle. SSL use is another one where you have to tweak and twiddle the frameworks and the defaults may not be secure. Using these freely available scanners, you can very easily write good enough checks, because you're just scanning configuration, to figure out if the developer has invalidated a secure default or actually upgraded the default to something that is secure. SemGrep is something that's been talked about by Clint in OWASP. SonarQube is a widely available open source tool, and of course with the Microsoft acquisition of SEML, there's a more powerful abstract interpretation engine that you can use to do fancier things. You don't need to be fancy. Glorified grep, semantic grep, is sufficient to make sure that these config checks get done what you need to be done. Go through the OWASP top 3. Go through the framework documentation. A lot of the framework maintainers describe what you need to do for security, and make sure you have checks. Implement those checks in whatever, think about this in terms of GitOps. Whether you want to mandate it on check-in, whether you want to do it asynchronously and generate pull requests for the developers, your culture in your organization will need you to tune how you apply these checks to your tolerances. But what I'm saying is that the underlying primitives provided by the frameworks are good, and your ability as a security champion or a security group participant is to use these freely available tools to make sure that the right thing gets done. Now, we have to build on top of a secure base in addition to the code we write. So we, of course, want to use dependency tracker, Dependabot, to make sure that our use of open source, is in fact secure. We've all focused on composition analysis here for, the last 3 to 5 years. I'm not going to dig into that in detail. Again, we have an OWASP flagship product that makes a ton of sense to use there. Some organizations are gonna really plump towards the auto fix and the pull requests. Others are just going to want the scan data and want the engineers to handle that. Again, culturally, make the fit that works for you. Use these technologies. The Amazon well-architected tool is something we want to add to this. So containers are like Legos. There are security responsibilities, security APIs. There are configuration demands on the way we build and provision our architecture. Using something like the Amazon well-architected tool, if you use AWS, is a means by which you can secure not only the open source base on which you build, but the topological and infrastructure base on which you build as well. Finally, you can apply either a cloud-specific or a multi-cloud, like a Scout solution, to scanning the infrastructure as code configuration to make sure that you're not doing something like exceptionally overbroad permissions in your perimeter, or putting persistent storage or queuing out there that doesn't have permissions on it, or doesn't have authorization checks on it, or that isn't encrypted. Now, the challenge that you'll face building a security program around these tools, in the code side, you may get as much with modern frameworks as 80% or more effectiveness with these open source tools as a commercial tool, based on my experience. With Dependabot and well architected, you'll get, again, a robust performance out of the open source that you can build a program on. Mileage may vary, but these are good tools. Now, as we move over to infrastructure, there isn't a cloud top 10 per se. There's CIS, benchmark, and other things, but there's sort of, that's not bottomed out with the maturity of the OWASP, AppSec top 10. When I look at the rules inside of both the cloud-specific and the multi-cloud tools here, the IP is really sparse. So you'll get the lowest hanging fruit, but you're going to need to augment these tools inside of your organization with more checks that derive to your standards for securing and hardening this infrastructure. And something there isn't a good open source check for is the configuration management. So it's much easier to scan somebody's Amazon config than it is to scan their Ansible or their Terraform or their even their Helm charts and evaluate those for security. Why? Well, because the definition of an EC2 instance or something similar in the cloud configuration has really simple edges and really simple properties. It's a bucket, it's encrypted. Because the configuration management tools can actually act on these entities, glue them together, change their behaviors, you have to model a bit of what they're doing in order to get a security scanner to work there. There are some commercial tools, and we'll talk about that a bit more later, but this configuration management is a huge gap in the vulnerability discovery space right now. And the reason is because, frankly, it's harder, and I don't think people are really aware of the outsized impact on posture that this has. So we need to focus on this problem. We've all got a pretty good handle on things like SAST, SCA, and DAST. Other people are using things like IAST. All of that is fine. We've taken our secure coding standards and we've converted them into vulnerability discovery, remediation practices, and training around those legacy technologies. In my mind, we really need to focus on figuring out how to take the things we talked about in terms of coding standards, don't call this function every time before you do this, and convert those into security blueprints for the kinds of entities we're instantiating when we build and connect containers, when we configure and deliver cloud-based assets through CSP config, and when we orchestrate the combination of those things into microservice meshes or applications with infrastructure as code. The advantage we get when we shift from the left to the right here is that we can begin to look at the way that CTO office and CISO office want applications to look and say, if you stay within our security blueprints, if you use our verified snippets, it's going to be much easier, or we can skip the auditing of your infrastructure, we can skip the audit of your mesh because you followed the blueprints in the ways you created it. And so we've always talked about security standards and secure architecture and getting leverage on this stuff for years. Finally, infrastructure as code gives us the ability to apply this positive lens to the scanning problem and to get this kind of positive attestation out of our development. So while we're shifting to open source and GitOps and scanning things as we check them in with open source, as we shift to where the code and the churn is and look at our infrastructure as code and our cloud service provider configuration, we also need to evolve past run a scan and produce a report. Remember that self-service driver, and remember the cadence challenge we had, right? If it takes 7 hours to run a scanner, if it takes 2 days to get a manual pen test done, you can't do continuous delivery. So the third thing we need to do is we need to evolve past the scan and the report. Now, almost every individual tool has Jira integration and something similar, right? Chat ops, whatever, right? This is not what we're talking about, because I've seen organizations go from running 5, 10 tools and producing 5, 10 reports to producing 5 to 10 integrations between their security scanning tools and their chat ops platform of choice or their change management systems. All they've done is remove the paper from the process of creating that developer insurgency where an avalanche of vulnerabilities, an avalanche of change requests comes in. So we spent time from a legacy perspective optimizing those touches and converting our policy documents to gates in our delivery process that executed and either broke the build or did some other big red button activity based on scanning rules. Over the last 3 years, we've optimized the notion of gates and rules, and we've created policy as code. Some organizations have gotten very clever about running as much scanning as is warranted by the application or as is warranted by early scanning. Some organizations have used total vulnerability management tools or other tools. This category is kind of misnamed, and said I'm going to combine the tool's results before I submit something to the developer. Maybe I can correlate findings so they have all 10 pieces of information on their desk at once when they make a code change or a patch. All of these approaches are an optimization of the point-in-time scan-based modality. And when you look at the way that engineering-led security initiatives work, they don't take that approach that the legacy and central security initiative took. Instead, they say, we're not going to optimize. Instead, the legacy, gated approach. We can't stand in the way of delivering software. Instead, we're going to take the notion of security policy, we're going to replace it with blueprints like we described in the last slide. And then we're going to make sure we can detect drift off of those blueprints, whether it's a hardened container, whether it's a verified instance config in the CloudFormation templates, whether it's whatever. And finally, we're going to leverage technologies that allow us to put guardrails on the way that that orchestration software works and what we're able to do in terms of predicting what the resulting service mesh will look like or application will look like, and make sure that it conforms to our desires for authorization or use of east-west encryption or any other number of security standards or blueprints. The difference between a guardrail and a drift-based approach is that you're defining what secure looks like proactively, just like you tried to do proactive scanning. But you're moving from a point-in-time scan-based approach to a real-time runtime approach, that says, I'm not really going to know what the posture and the software looks like until it's running. So I will make sure that the things that I hardened don't change, drift detection, and I will make sure that if anything violates a policy, that I get an event in real time. And so you've seen organizations, treat security telemetry that used to be vulnerability discovery reports more like SIM telemetry than reporting. And because they're moving not to the thousands of static analysis or dynamic analysis rules and the report that kills a tree, but because they're looking at those few things that tell them if developers are using the frameworks correctly or sticking to the hardened configuration, they can afford to immediately send those events back to change management or through the SIM or their desired focal point, because staying on the guardrails is a lot less noisy than finding thousands of vulnerabilities, of which half or more might be false positives. Now, what do we need to do as security? We need to far transcend our desires for CI/CD automation and scanning rules and converting our policy documents to automated scanning. We need to go beyond what members of the BSIM community have done and try to implement policy as code. If all of the developer technologies are simple YAML configuration and they're checked into the repos, then the policies that govern both the blueprints and the vulnerability that configuration may possess also need to be configured. And when we're managing our security scanning by creating policy as config and doing GitOps on our policy, on our governance, just like development is, then and only then will we have the ability to match the scale and leverage and the cadence of the development organization. And that's going to require, that'll create governance on their governance on the governance that development provides. Now, why their governance? The subject matter expertise necessary to comb through the development frameworks, the infrastructure as code platforms, and the cloud service provider APIs, of which there are more every 3 or 4 weeks, is going to overwhelm security groups. So enrolling security champions, enrolling developers in self-governance, and having them participate in the authorship of this policy configuration is going to be essential to hitting the breadth of technology support you're going to need in your organization. Some organizations are actually going after technology-independent policy description and have created, there's one organization that's created a technology-independent policy language where you can, in their UI, create a policy for encrypting storage or authorized use of a cloud-based asset. And the technology then converts that policy down onto the different ways that a particular cloud service provider may manifest that, whether it's S3 or RDS or a Q, and so on and so forth. Technology-independent definition of that policy configuration, and then managing that as GitOps is kind of the brass ring for now. In my searches, I've only seen Concourse Labs, a startup, do that level of abstraction. But that's where a security initiative with a multi-hybrid cloud scenario is going to need to go in order to keep pace with converting what they're doing to govern each and every one of those cloud platforms and the use of the infrastructure technologies. So there's some key challenges with this evolution that we're going to undertake. I believe myself or a colleague was the first to say shift left, maybe back in 2001 November. Shift left in this situation where we're moving more and more of the code, the infrastructure as code, to the right, has become a tribute left. In other words, we may have to scan things that either execute or that generate behaviors right in the life cycle, and we're going to have to attribute those failures to the or the change requests to the people in the developer seat that's necessary. As we move throughout the life cycle and find more and more different places to collect telemetry from and attribute that to the left, and as we remove scanning and reporting because it doesn't fit our cadence of delivery, and we begin to provide more ad hoc or event-driven change request material, engineers will consume events continually once attributed to them. And security executives will ask the question, what does measurement look like? What does it mean to have defect density? How much cover do I give the developers to fix things? Do I track that? Are they going to game that? If I was scanning quarterly and reporting to the board annually, how do I track the change? What we found this year in the BSIM study is that organizations are dealing with the answer to the question of how to implement a scanless, continual vulnerability discovery program, and what they're going to do to make sure that doesn't create an avalanche of findings, make sure it doesn't overwhelm the developers, make sure the cadence of delivery of that is commensurate with things like sprint planning and other exercises, and make sure that the measurement that goes along with that is compatible with the way, or at least similar to the way that they did it historically. If your organization isn't thinking about how to get to a continual feedback loop with developers and maintain the level of security reporting that it had, this is something you're going to need to begin to concentrate on. Moreover, again, there is no silver bullet tool. You're going to need, in Gartner's mind, 10 to 30 tools to get cloud fragmentation under control. Certainly the average security initiative has 3 to 5 security tools in play at least. Cohering the results or the events from all of those different pieces of telemetry and making a single coherent risk view. These two things are the same. This is it in the config, this is it in the code, this is it in the behavior that we tested. Here's all 3 pieces of information to a distributable party so they can decide the best way to fix that. That holistic view in converting those pieces of vulnerability or defect telemetry into a risk view and reporting that between engineers, between engineers in the business, and between business and customers is the second thing BSIM organizations are focusing on doing in our last study. Now, these two things are advanced. They're in the 3 tier of BSIM activity, which means that only the most mature organizations are the ones that are wrestling with these problems. Their wrestling with this problem is a harbinger that the mid-market is going to need to wrestle with these problems, or that we're going to need tool vendors or pipeline vendors to begin to help us with these problems before it hits the mid-market. These challenges are reflected in the way a modern lifecycle actually works in a mature security initiative. This is a slide I presented last year at BSIM for a keynote. And what you see about this slide is there's a million different lifecycle slides, that show an infinity, others that flatten it out into touch points. I chose this representation because it shows 3 different phases of telemetry coming back through security to development. There's the IDE, there's your SCM, and there's the build pipeline. These are the mechanisms that developers use and the places that security hook telemetry in to provide building security in to developers. Now, the dynamism of software has dictated that more and more of what the software is going to look like and behave like in production is going to happen up here in this artifact repository, containers and images and orchestration piece, telemetry from, sort of CD. Now, there are plenty of development tools, registries, frameworks, platforms that support this, but other than the container security market, you don't see a lot of security telemetry servicing this piece of the puzzle. And then, of course, we have rate of release and production and the kind of telemetry that typically goes to operations out of that piece. This modern life cycle and the different cadences associated with what is allowable from a security telemetry latency perspective is really interesting. And it's what the BSIM community was struggling with last year as we went through this process of really engaging with infrastructure as code, with orchestration, with move to cloud. And they wrestled with how they were going to adjust the telemetry that was really front-loaded to the left into this new dynamic environment. And what firms realized and what they began to reflect in their behaviors is they were combining the events that came out of the stuff that they ran when they scanned builds with the stuff that they ran when they built containers, orchestrated the combination of those containers and delivered them, and the telemetry they were able to instrument production with. And so whether you're using a commercial tool or something else in here, there needed to be a way to figure out if a piece of behavioral information from production and something you could glean from infrastructure as code or containers and something you pulled from defects was the same thing or related and needed to go to the same attributable developer. So as the first or second person who said shift left in the world, I'm here to tell you now, focusing AppSec's efforts in the next 12 to 24 months means giving up the focus on shift left and thinking about how you're going to combine different pieces of information from the left when you build, from the right after you deploy, and from even right of boom when something goes wrong. You're going to need a mechanism, and if you don't want to buy one, GitHub and GitLab have exceptional ones, to combine those things and route them to the right developer or engineer. And the dynamism of, modern software languages, web development frameworks, and the way we develop and combine and orchestrate software with containers is going to necessarily demand we shift right to get more accurate or to get lower latency visibility into the security properties of our components, of our services, and our applications. The more right we shift, the faster we may go, the more accurate telemetry we may get, but we're going to struggle with attribution. The longer we wait, and if we try to be resilient like the Netflixes and the Amazons of the world are, we take a resilience-based approach. We say we can't build things perfectly. What we can do is make sure that we're able to identify, attribute, remediate, and or risk manage and redeploy instantaneously. That's a resilience argument. That's a struggle for firms. So safely navigating a purely right of boom phenomena, as some organizations try to do, is going to require a lot of maturity. In my opinion, as a result of these challenges and where we need to focus based on dynamism, AppSec is really going to need to focus on this middle, what I call the center, orchestration and containers. We focus on the ability of giving developers and engineers the ability to scan infrastructure as code and scan containers and scan cloud security provider, service provider configuration and attribute that to the right engineers. We're really making a difference. What's next? We've spent years trying to make sure that engineers can interact with our solutions, that we can monitor, adjust, and respond to their complaints about accuracy, their complaints about cadence. We thought that solutions must integrate with the approved technology stack, and we had to meet them on their side of the river, Slack, Jira. We're doing a much better job of meeting their cadence, meeting their self-service requirements when we can scan all the languages they use. And we recognize the languages they use are infrastructure as code, their cloud service provider configuration, they're basically config. And we need to give them not only the ability to scan those languages, but we need to give them the ability to self-service the definition of vulnerability checks. Don't do this, it's always dangerous. And guardrails. Do it this way. Our architect office and our security architects like it this way for themselves. Because remember, cut and paste is still the way people develop. And if they're cut and pasting their guardrails and their secure or hardened snippets and their checks, then we're going to get leverage out of the security side of the house. We must give development the ability to operate, monitor, adjust, and respond to those guardrails themselves and consume reporting off of it at the cadence we need, while providing back to them expertise just in time to their OODA loop. We must provide traceable and immutable attestation for what those things found, attributable to those artifacts, because those artifacts may be extremely ephemeral, or they may be long-lived and persistent in a gold source that's potentially public. So not only do we have to create this scanning capability for things like infrastructure as code, for cloud service provider configuration, but because someone may use those snippets and create something that lives for a while, when there's a problem with that thing, we need to attribute it back to the policy we scanned it and what security nutrition information was associated with it. Because developers and engineers will self-service the creation of these assets. That's 3 buckets, VPCs, services, containers. We need the enrollment of the scanning and of the telemetry in these assets to be automatic, along with the creation of them. Security on and there by default. We've seen this happen with SCA. If you're using OpenShift or you're using GitHub, you get SCA for free. It's in the UI. It's business as usual. You get the alerts. The security configuration for the SCA scanning, as well as how you build and how you define dependencies, is configuration. So the security control is config already. And the ability to manage right of boom or security research inbound is integrated into the platform and meets developers on their side of the river to respond or to notify customers. All of these slides are a year or 2 old. Why? Because SCA and because the pipeline platforms are solving this security from an engineering-led perspective problem as a necessity, what I said earlier on in the presentation. So if you listened to this presentation and said, that's too hard, understand this is where GitHub and GitLab already are. If you're a security vendor, watch out. If you're an organization using security vendors, think about this. There's going to be a tension over the next 12 to 36 months. People are going to want to use infrastructure as code to create these trust boundaries between things like containers and production, things like repos and other developers, and create gates again. Governance, people want to be governing. The people from organizations like the Netflixes and like the Etsy's and like the Amazons who think about resilience and who say, I'm going to flex. I'm going to use agility at its extreme. I'm going to respond. Those two things are going to be at odds. This is a slide from this year's BSIM where organizations are going to be encouraged to create trusted boundaries. Some firms that'll work with, other firms it will not. There's going to be a natural tension between DevOps and AppSec luminaries. Policy will try to be enforced as gates, even when it's configured, it'll be easier. Gates will always get in the way of delivery. So the question is, how can we focus on the things that we know will work, and we know will work for engineering-led organizations, we know will work for governance-led organizations. Everything's becoming code, we need to be able to scan it. We need to be able to scan it when it's checked in, we need to scan it when it's shared, we need to scan it before it's run to create assets. We don't have to gate based on what those scans tell us, but we have to deliver that telemetry to developers immediately. It has to get to the right developers. It has to be combined with other information to help them make good decisions. And we have to learn how to get rid of that scan cadence and focus on that. If you take nothing else away from this presentation, remember, in the past we tried to shift left. Getting an accurate picture of your software's security posture requires you to look left, to look right at behavior, and to absolutely focus on that orchestration, the cloud service provider config, and the container constituency in the center. Look in the center. That's where your program's weak right now. Probably. Correlate and focus on routing that telemetry from left, center, and right to the right engineers. Maybe multiple engineers. One to handle a Band-Aid and one to handle a proactive fix that's more long-standing. If you're still writing security policy and building big box checks, and you're thinking about policy as code, skip it. Think about how to do governance as config. Developers are thinking about how to scale pipelines as config. You will need to do that too. Guardrails will be the cultural instantiation of standards and for vulnerability detection and of proactive measures. And when it's defined as config, it will be executable and it will be human readable, which is the best of both worlds. Auto remediation is becoming less of a toy and more as something that really works. And it's the functional implementation of collapsing the penetrate and patch loop. Where you can auto remediate, fine. Where you can't, provide guardrails. It's still the code, stupid. Just understand that the code is becoming config for the web development frameworks. It's becoming config for the containers construction. It's becoming config for the orchestration that cobbles together the containers, services, and applications that build the business application. Go to where the code is. Understand that in that orchestration layer, we have a massive technology gap as it pertains to scanning that code, and we need to fill it right now. Find vendors that can scan your cloud config and your infrastructure as code. And check in all your code and make sure that it's being applied, the scanners are being applied to it. The beauty of infrastructure as code being config is that it makes technologies that got long in the tooth and that tried to maybe tackle too much commercially tractable again. So look at those open source solutions and see where they can apply if you can't find a tool to do the job for you. As I think about security, I usually give a very negative talk about how technology is changing and security can't keep up. The thing I want to leave people with today is that this transformation to self-service that developers are undertaking, this reliance on reusable things like containers, pipelines, infrastructure as code, cloud config, it's actually a godsend. Our ability as security to skip over the kind of linear automations and scale we were looking for, champions, policy as code, scanning rules. Our ability to skip over those things and meet developers in self-servicing security configuration and guardrails as config. This is it for us. We need to get on this train. And I encourage everybody to go learn these technologies and get on this train in your organization. Because missing this train means that the engineers will have defined what security means as they self-service IT all the way up. If you engage them and learn these technologies, you have the opportunity to meet them at the point of scale, at the fulcrum right now. And this is absolutely an essential and exciting time to be a security person as a result. Thank you for your time and attention, and putting up with this weird format. I wish I could have been there in person to see all of you.
Thank you, John, for that great presentation. If you're interested in hearing more from John, he'll be holding a Q&A session right after our closing remarks. But the conference isn't over yet. Our virtual expo hall is still open now until 5 p.m. You still have a chance to chat with our sponsors and enter the scavenger hunt for a chance to win a $500 Amazon gift card. Our virtual career fair will be taking place tomorrow morning. Log in at 9 a.m. to speak to live recruiters. And we have one more round of live networking sessions happening this afternoon. Now I'll turn it over to the OWASP Executive Director, Andrew Vanderstock.
Thank you everyone for attending this brand new AppSec Global. We obviously are in a difficult time with the COVID, but this has actually been an unbelievable experience for us. We've learned so much during this event and we're going to be doing more of them next year. So thank you for attending. I hope that you actually make full use of the remaining time to review all of the talks that you haven't yet seen and have a look at the expo booths. Talking about that, here are our sponsors, and thank you so much. Without the sponsors, we would not have an event this year, and they've really taken a chance, betting upon a virtual event. It actually has worked out really well. We've had a lot of hours being broadcast, and I think if you could help us out by helping the sponsors out by visiting the expo booths, looking at what they've got to offer, and entering into the swag and prize competitions, that'd be really good. So thank you again for our sponsors. So we've had over 1,600 attendees, and this was one of the larger events we've ever held. We have held some pretty large events, but we're actually doing so well that even after we go back to doing in-person events, we're very likely to continue having at least 1 or 2 of these global AppSecs in a year, just simply because it has been quite successful. We've had over 84 countries registered to attend, which is remarkable. We'd often get people coming in from overseas, generally from the speakers, but this has been truly remarkable that we've had such great coverage, and it shows the thirst for high quality content, and we're going to be continuing to do that next year. We obviously have over 40 hours of on-demand presentations that you're still able to access. Many of those have been viewed many hundreds, if not thousands of times. I've personally, I tend to attend an event and I'll go to 3 or 4 event, talks a day. I've actually seen over 20 of those. This is an amazing way of, instead of getting death by Zoom or having to do things in a compressed time period, when I've got time, I can watch a session. This is actually really good, and it's a new way of consuming the leading edge information that's available in our industry. So again, a call to action, please become a member. We are looking for people to become individual, student, regional, and lifetime members. For leaders who are active and you've been in the job for more than 6 months, we are actually offering complimentary membership very shortly. Be on the lookout for that. Become a sponsor. If you're a corporate member or corporate event sponsor, you actually have access to a very large audience, and it is wonderful to see the support that we've had for this event alone. We do have corporate membership packages, and we are looking for people to join the corporate advisory board. Create or join a project. This is the lifeblood of OWASP. This is what we're famous for. Come for projects, stay for the chapters. Our community, there's local chapters. We've got heaps of virtual events happening at the moment. I would recommend that if you're a chapter leader and you haven't held events virtually yet, please do reach out to us. We've got plenty of options available to you through both Meetup and through running Zoom meetings. We actually do have the ability to run very, very large virtual events, including the size that you're seeing today. I would recommend that if you're interested in running a regional event in your area, we've done some recently, for example, AppSec Africa. We're going to be running AppSec Indonesia shortly. Those would only be possible with local members working tirelessly to create a local event for themselves. The next 2 events are actually going to be AppSec Israel and AppSec Indonesia. I would strongly hope that you could actually attend those if you're in the area. Please feel free to join committees. The committee's business is completely transparent. There is an OWASP events calendar that you can join, and the committees and the global board meetings should be advertised regularly. The global board held a global board meeting on Tuesday this week, and that would be normally something that we would do every single normal global AppSec event. I would strongly recommend that you do attend global board meetings if you're interested in the governance of the foundation. Lastly, in 2021, we will be doing a fair amount of fundraising, donations, and we will be doing sponsorship drives and membership drives. Please support our efforts in those areas, either financially or get out there and help us do the fundraising, donations, or membership drives. We really do appreciate everyone's help in sustaining the OWASP community. Thank you so much to the OWASP staff. Alana and Emily and Kelly have worked tirelessly to get this event running, so I particularly call out those folks, but everybody here has pulled together and really made OWASP what it is this year. We are looking forward to a fantastic 2021 when we put this COVID thing behind us. I would strongly recommend that, if you've not said thank you to our staff for helping you, please do reach out to them. They love getting positive feedback. Closing remarks. It's time to rebuild OWASP. The foundation has, for its first 19 years, sort of gone from thing to thing to thing to thing, and we've done pretty well for ourselves. We've become the global organization that is known for AppSec. There are very few that are like us in terms of size, reach, or impact. And I want to see that continue, but we need to focus on our mission. This year, we've seen some pretty terrible community interactions where people have been pulling each other down. It's time to end that. The community is running the community. And to do that, we need everyone to pull together. And we can only do that if we help each other. If you're pulling people down, I'd like you to leave. If you're helping people, mentoring, building projects, running chapters, helping people, answering them on Slack, that is exactly what we're famous for. If we're becoming famous for being a toxic community, then that's not a good place for us. It can kill our entire community. And in fact, that's the reason why I'm doing this presentation. Our chair felt that it was not the right time or place for him to actually do this presentation. That's incredibly sad. I like to think positive. At the end of the day, if we can start building up everything again in the way that's an OWASP way, we will get there. If we start thinking about DevSecOps and working with developers, not against them, with our community, not against them, and building up the next generation, we will have a fantastic next 20 years. I need everyone to come along for this journey. And the only way for you to do that is to participate. If everyone is busy yelling and screaming and talking past each other, that's not going to happen. Join in and become part of the solution. Don't be part of the problem. Again, I'm looking for positivity here. We've had positivity for many, many years. And for whatever reason, 2020 has been a terrible year for many people. And I think it's brought out the worst in some. And it's time for us to put all of that behind us and get going again with what OWASP is about, which is helping build secure applications. We can only do that together as a community. We can only get the mind share with developers if we're pulling together in the same direction. That direction is now reasonably well set, but the details, the devil is in the details. How we get there and what we do, we need to build these things together. The photo you see there are some of our most active people in our community. For example, Dr. Dirk Wetter, Spiros, who's the driving force behind the outreach and the chapters committee. And, at the end of the day, I really want to make sure that we are all able to have happy, smiley photos in everything we do at OWASP. If we're actually fighting each other, that's not going to be like that anymore. I want to build this community up. I want to get to 10,000 members. I want to have 1,000 projects. I want us to be deliberately involved in setting the agenda for application security, not only in the next 20 years, but over the next 5. The only way for us to do this is to refocus on our mission and give up all of the drama and all of the negativity. Just let it go. Put it behind us. Work with the people that you felt that you weren't communicating well with. I've done this. It's really important that the community comes together now. We've had a bad year. Let's put it behind us and work very positively on events, chapters, projects, and of course, getting out there and promoting the application security mission. I really encourage everyone to get involved. So, see you next year. I'd love to see you in person next year, but in all likelihood, it's going to be a virtual event. However, we are looking at running a physical event in Australia next year. More details as they come. Our next virtual event will be in May to take place of the Dublin event. We'll announce those details and a full calendar of events very shortly. Please keep your ears posted for any signs of new events. And as I said, AppSec Israel is coming up very, very shortly, and AppSec Indonesia is coming up shortly as well. If you're in those regions, please participate. I would strongly recommend getting involved in any regional events. Thank you. Thank you for your time.
Thank you, Andrew. For those of you interested in that Q&A session with John Stephen, click the link in the description below. You'll be muted when you enter. In order to ask a question, you can do so in the chat. If we need you to elaborate, we'll unmute you. Sadly, we only have room for 500 people, so the first 500 folks will be able to join. Thank you. We hope you had a great conference, and we'll see you next year.